Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. To your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. There is another video in Engineers in Progress, particularly on the topic on slope, area by coordinates, and angle formed between two lines. So I hope that through these problems, you will be able to increase your knowledge in algebra. So here is the first problem. The line segment drawn from point P, which has coordinates x, 3 to 4, 1, is perpendicular to the segment drawn from -5, -6 to 4, 1. So find the value of x. So this is problem 35. For perpendicular lines, the product of their slopes is -1. Remember that. So plotting, you have x, 3, 4, 1, and -5, -6. So call this M1, and that's the slope of this line as M2. Slope of M1 is delta y, 1 minus -6 all over 4 minus -5. And the slope of M2 is 3 minus 1 over x minus 4. And the product of slopes is -1 for perpendicular lines. 7 times 2 is 14. Then this is 9 times quantity x minus 4 is -1. So 14 over -9 equals x minus 4 after we cross multiply. So x is -14 over 9 plus 4. 36 minus 14 is 22 over 9. So that's the x coordinate of the point x, 3. Then let's have angle formed between two lines. So let us say we have first line, second line. The second line is the terminal line because the angle should be measured in counterclockwise direction. This is line I, initial line, and the angle it makes with the positive x-axis is theta I. So line 1, line I. So that's theta I, this is theta T, terminal, and that is theta, which is the difference between theta T and theta I as shown in the figure. So that's theta T, and this is theta I. So from the figure, theta is theta T minus theta I. Therefore, tangent of theta is tangent of theta T, quantity tangent of theta T minus theta I. So tangent of theta is tangent of quantity theta T minus theta I. So from trigonometry, the expansion of this function is tangent of theta T minus tangent of theta I all over 1 plus tangent of theta T times tangent of theta I. So that's from trigonometry. So you also review trigonometry. I have playlist in trigonometry also. So tangent of theta T is slope of the terminal line, tangent of theta I, slope of initial line, then all over 1 plus slope of terminal line times slope of initial line. So tangent theta is slope of terminal line minus slope of initial line over 1 plus product mt times m sub I. So this is the formula, but I suggest do not memorize. You just determine the slope, Then from there, you can determine the physical meaning. You can compute for the slope that the line makes with the x-axis. So this formula should not be memorized. Thus, for parallel lines, theta is 0. So if the terminal and the initial lines are parallel, then theta is 0. So this formula here is only 0. Remember, tangent of 0 is 0. This will only be 0 if the numerator is 0. That is, the slope of the terminal line equals slope of initial line. So tangent theta, tangent 0 equals 0. Slope of terminal line minus slope of initial line all over 1 plus product slope of terminal line times slope of initial line. So this is 0 if the numerator is 0. So conclusion, slope of terminal line equals slope of initial line. Then for perpendicular lines, tangent of 90 is undefined. And this will only be undefined if the denominator is 0. So that means we have to equate the denominator to 0. So for perpendicular lines, the product of their slopes is -1. So that's it for angle formed between two lines. Then for parallel lines, the condition equal slopes. Then for perpendicular lines, the product of the slopes is -1. Then let's develop a formula for angle or for the area of polygons, closed polygons. So the idea here is we just form, so let us say we have points arranged in counterclockwise direction. That's the condition. So I just have a triangle because a triangle is also a polygon. Then we enclose this with figures, geometric figures that are known, like rectangles and triangles, right triangles, as shown in the figure. So points should be arranged in counterclockwise direction. So this is x3 minus x2, right x minus left x. This is upper y minus lower y, so y1 minus y3. Then x1 minus x2. This is y1 minus y2. This is x3 minus x1. y1 minus y2, and this is y2 minus y3. So the area is equal to area of rectangle x3 minus x2 times y1 minus y3 minus area of this right triangle 1/2 of quantity x3 minus x1 times y1 minus y3 minus area of this right triangle 1/2 of quantity x1 minus x2 times y1 minus y2, and lastly minus area of this triangle 1/2 of quantity x3 minus x2 times y2 minus y3, so that you don't need to memorize. So forming that area of rectangle minus areas of three right triangles, the result in general, so in general, the area of a closed polygon would be 1/2 quantity. So arrange the points in counterclockwise manner, beginning with x1, y1. So the next point should be 1/2 quantity x1, y1, x2, y2, then x3, y3, x4, y4, and so on and so forth. Then this is the last point, xn, yn. Then it should be closed by going back to the first point, x1, y1. So the calculation of area is positive in this direction, just like evaluating the determinant, like that. Then negative in that direction, up to the right. So area equals, so you just arrange the points in counterclockwise manner to make sure that the area is positive. So this will result to positive area. So note points must be arranged in counterclockwise manner. So this is the example. Determine the acute angle between the line segment drawn through -3, -4 and 5, 2 and the line segment through -6, 5 and 4, 3. So plotting the points, we have -6, 5 and 4, 3, which is that. Then -3, -4, which is this, and 5, 2, which is that. So these are the lines. So if you use the formula, so this is the angle between the two lines in counterclockwise direction. So this should be the terminal line, and this is the initial line. The slope of the initial line is 3 minus 5 over 4 minus -6. So that would be -2 over 10 or -1/5. So that's the slope of the initial line. For the terminal line, it is 2 minus -4 all over 5 minus -3. So that would be 6 over 8 or 3/4. Substitute into the formula, tangent theta equals slope of terminal line minus slope of initial line all over 1 plus slope of terminal line times slope of initial line. So terminal line, it's 3/4 minus initial line -1/5 all over 1 plus 3/4 times -1/5. So this is 15, 5 times 3, 15 plus 4, 19 over 4 times 5, 20. The denominator is 20 minus 3, so 17 over 20. Cancel out 20. So tangent theta is 19 over 17, inverse tangent. So using your calculator, it is 48.18 degrees. For the second solution, we simply compute theta 1, inverse tangent of 1/5. We treat the angle positive. So inverse tangent of 1/5 is equal to 11.31 degrees. Then inverse tangent of 3/4. So that would be 36.87 degrees. So adding, so we get 48.18 degrees. So this is the other solution without using the formula. And this is the last problem. Find the area of a pentagon connecting the points 3, 0, 2, 3, -1, -2, -2, -1, and 0, -3. So plotting these points and checking if the points are arranged in counterclockwise direction. So 3, 0, 2, 3, -1, -2, -2, -1, 0, -3. So the points are in counterclockwise direction. So first, using the formula, area is 1/2 absolute value. Remember, the first point is 3, 0, next is 2, 3, next is -1, 2, next is -2, -1, then 0, -3, then back to the original point 3, 0. So area equals 1/2 of quantity 9 plus 4 plus 1, 9 plus 4 plus 1, plus 6 plus 0 minus, so minus in that direction 0, -3, -4, 0, -9. So -7, -9, that's -16, negative of -16 is 16. Then this is 7 plus 4, 11 plus 9, 20, 20 plus 16, 36 divided by 2. So the area is 18 square units. The other way is I enclose the figure with a rectangle. So we have 3, right x 3 minus 0, so that's 3 units. This is 0 minus negative 3, so that's 3 units. 0 minus negative 2, so 2 units. Negative 1 minus negative 3, so that's 2 units. Negative 1 minus negative 2, 1 unit. 1 unit. Then this one, 2 minus negative 1, 3 units. Negative 1 minus negative 2, 1 unit. 3 minus 2, 1 unit. This is 2 minus negative 1, 3 units. Then 1 unit, we already computed that. This is right x 3 minus 2, so 1 unit. 3 minus 0, 3 units. So the area of this triangle is 1/2 of 3 times 3, so 9 halves. 1/2 of 3 times 1, 3 halves. 1/2 of 3 times 1, 3 halves. 1 times 1 square, 1. 1/2 of 1 times 3, 3 halves. Then 1/2 of 2 times 2, 2 square units. So another solution, area equals area of rectangle. This is 5 units by 6 units. So 5 times 6 minus 9 halves minus 3 halves minus 3 halves minus 1 minus 3 halves minus 2. So computing area is also 18 square units. So that's it for this video. I hope that you were able to follow the explanations and the solutions, and I hope that you increase your knowledge in analytic geometry, or particularly algebra.